Hi, welcome to our pre-calculus topic today, proving an identity using fundamental trigonometric identities, problem type 3. So gradually we go to more and more complicated exercises. So here we want to show that 1 minus cosine times 1 plus cosine is 1 over 1 plus cotangent square. So what do you think we should do? Good idea is to pause this thing and do your best and then come back. So I see squaring here. I think about perhaps I create some squaring on the left hand side to match them up. And then I have difference of two things times the sum of two things. That reminds me of a basic algebra identity, which is what is a minus b times a plus b. So if I had uh, so if I had like a minus b times a plus b, I know that when I multiply, the so-called cross term cancels out, the ab and minus ba, these two cancel each other out, and all that's left is a squared minus b squared. So how does that help me? What I have now is starting from the left hand side, is okay, this is same as 1 minus, that means 1 means 1 square, which is same as 1 cosine, then square of x, and all I did was to do a bit of algebra, that's all. Validate. Next, 1 minus cosine squared, you remember that is sine square of x, excuse me, x, and then, well, we know, I've seen this so many times, well, I just don't I trust that you already know that that is Pythagorean. Now, what the sine square has with 1 plus cotangent square. So I need to kind of create a fraction here. Let me go ahead and validate first, and then let's turn this thing into a fraction. What brings us a fraction here? So let's see if I go to fractions are here. So what is sine? Sine is same as 1 over cosecant square. So I change the format of this from sine to a fraction with 1 over cosecant, and so here I will have, let's see, 1 over, and here's cosecant of x, cosecant to the power of 2 of x. So let's see if the software accepts it. I am doing two things at the same time, like instead of sine I'm writing 1 over cosecant, and then also I am squaring it. The primary thing here is that I used reciprocal identity. Let's see if it's happy with our action. Yeah, it's okay. So the primary thing here was using the sine being equal to 1 over cosecant, and of course we had to take that identity and square it, so we just allowed us to avoid writing too much. Next I want, well, what is it that we want to do? Instead of cosecant on the right hand side, I want 1 plus cotangent square. Who does where does that one come from? That's of course a Pythagorean identity. Which one of them was it? Let's go down here, list. What do we have for cosecant? For cosecant, we have 1 plus cotangent square. So all I need to do is to apply a Pythagorean. Let's choose that. And 1 over 1 plus cotangent square of, excuse me, cotangent square of x, and validate. So we are all set, and then we can go to try another one. Okay, secant squared minus 1 times cosine of x. We want to show that it is same as sine square of x times secant of x. So step by step, what I can do with secant square minus 1. Where does that show up? Secant square minus 1, that has to be in the category of Pythagorean identities. Secant square minus 1. Here, secant square. If I subtract 1 from it, all I get is tan square. Is that right? So that is going to give me tan square. So I write tan square of x times cosine of x. Now, tan square, what do I want to do? I want to go towards sine square secant square. So one thing I can do is to remember that tan is, by quotient identity, is a sine over cosine. So when I write it as sine over cosine, then when you square that, you get the sine square. And you have one cosine here and one cosine in denominator of tangent. They are going to cancel, and then you're going to get what you want here. So it's a bit of like traveling into a maze and trying various activities to see what you get. So tangent square. So what is that? So let's I have a fraction in the numerator. I have sine of x. Well, sine square of x, because sine square of x, and the denominator I have cosine square of x, and then I have cosine of x. So from previous to this one, what did we apply? We applied the quotient rule, because we said tangent is sine over cosine. Is that right? Quotient rule, here tangent is sine over cosine. That's all I applied here, and of course we squared it, and we noticed last time that software doesn't push us to explain that step. Okay, validate this, that's fine. One cosine and one cosine cancel out, so let's write a fraction again. So I have sine square of x, then divided by cosine of x. So one of the cosine here, one of the cosine here cancel out, and all that it takes to do that is just algebra. It doesn't have to do with trigonometry. Is that fine? Yes. All that is left, sine square stays. I have 1 over cosine square, which by ratio, by reciprocal identity, is the same as secant. So I say sine square of x, and 1 over cosine, you remember that is just secant of x. And well, what did we do? We applied the reciprocal identities. You remember reciprocal identities, be 1 over cosine, where is it? Yes, I had a hard time finding it. 1 over cosine is same as secant. That's what we are using here, and then we are all set. That is what we wanted to show. Let's see if we get anything more exciting. Let's see. Isn't that what we just did? When you say try another, there is a question in mathematics called choosing with replacement or choosing without replacement. Like you are going to see that in perhaps your probability courses and such. If you have a bag of items, you take something out of randomly out of the bag. You have something. If you set it aside and then pick another one, that's called picking without replacement. With replacement means that you put back whatever you had originally, and second time that you draw from exactly the same bag that you had at the beginning. So here on Alex, when it says try another, it randomly draws from whatever that is out there, and it's not necessarily something different. So that's what my lengthy discussion was about that. Let's see. This is close to what we had. Let's see. Cosecant square minus 1. Cosecant square minus 1. That is looking like a Pythagorean. Cosecant square minus 1. Okay, that if I take the 1 to this side, I get just cotangent square. So let's go ahead and write that. I have cotangent square. So I have cotangent square of x, cotangent square of x, then times, second one is still there, secant of x. Where do I want to go? I want to go to cotangent cosecant. So what can I do? I can keep one cotangent out and then write this thing as cotangent times secant of x, and see what does that going to get me. So let's verify this. So cotangent of x times another cotangent of x times secant of x. So what did I do? I'm not sure. It requires us to tell him that that's what I did. I just did algebra, so that is not a big deal. Next, say, okay, let's keep one cotangent and try to go after the cosecant of x. How can I get so I have cotangent, which is what? Which is cosine over sine, and this is 1 over cosine. So let's write cotangent of x. Instead of cotangent, I'm going to write a fraction. Oh no. I step to the right and then I use the fraction. Let's see. No. Well, it wasn't helping me out, so let's do with a parentheses. So I do a parentheses and then I will do my fraction. Okay, that was, I forced him to step to the right. Instead of cotangent, I write cosine of x in the over sine of x, and then I have my parentheses closed, and then I have cosecant of x, so that is cosecant of x. So all I did is that cotangent is that ratio, and that's a quotient identity. So let's see if it's happy with this quotient identity. I did quotient, validate. Oh, this is saying this line is incorrect. What is incorrect about it? Oh, I see. When I copied over, so instead of cotangent, I write cosine over sine. I was supposed to type secant of x. So let's see if I correct myself. Secant of x, quotient identity. Let's see. Now it's happy. Next, I go write cotangent of x. Then parentheses, I have fraction cosine of x over sine of x, and then now instead of secant, what is secant equal to is same as 1 over cosine. So I write another parentheses, another 1 over cosine of secant is 1 over cosine. Is that right? So what we did here is that we applied reciprocal. Well, secant is a reciprocal of cosine. Okay, now I cancel my cosine and cosine, so I have cotangent of x, and then divided by, let's see, all that's left in the denominator is sine of x. So all we did here was some algebra. Are we okay? Yes. Now 1 over sine of x is the promised cosecant of x. So I have cotangent of x times cosecant of x. And the rule that we are applying now is the reciprocal identity again. So reciprocal, I applied the reciprocal, validate. Thankfully we are out of this problem. Again, when you write it by hand, it's a bit faster than this, but here we are going step by step. So we are going to go to type 4 and see what's available over there for us. Until then, good luck and God bless.